Today's notes are on section 6.5, Factor Theorem. You should have already tried the warm-up, so please check your answer with the one on your screen. 2x minus 12 plus 84x squared minus 69 over x cubed plus 7x squared minus 5. The factor theorem says a polynomial f of x has a factor x minus k if and only if f of k equals 0. What does this mean? If you do long or synthetic division and the remainder is 0, then the divisor is a factor of the original polynomial, and the solution polynomial is the other factor. So for example 1, we are going to determine if x plus 7 is a factor. Remember when doing synthetic division that we set x plus 7 equal to 0 and solve to get x is equal to negative 7 to tell me what number goes outside. And then I'm using my coefficients in descending order by degree, making sure that I include 0 for any missing terms. So for this one, I'm missing my constant, so I'm going to replace it with a 0. Then we're going to go through the process of synthetic division. So I bring down the 9. We multiply and add, multiply, add, multiply, and add. We're checking to make sure we get a remainder of 0, which we do. So this confirms that x plus 7 is a factor. Please try example 2 on your own. Determine if x plus 10 is a factor of the polynomial. You can then use the factor theorem and the factor rules to factor higher degree polynomials. So if we look at this again with example 3, 9 is going to go on the outside. My coefficients are 1, negative 18, 95, and negative 126. And we're going to go through and do synthetic division here. And we get a remainder of 0, which tells us that x minus 9 or x equals 9 is in fact a factor. So we can then take the bottom line here. So we know we already have x minus 9. We can turn the bottom line into a polynomial starting 1 degree less than the original polynomial. So this gives us x squared minus 9x plus 14, and I can factor that polynomial further. We need to think what two numbers multiply to 14 and add to negative 9. That's going to be a negative 7 and a negative 2. This would be your fully factored polynomial. Please try and use the same properties to help you with example 4. Find that x equals 6 is a solution. Use that to synthetically divide, and then factor the polynomial that is the result of that. Then flip it over and look at the next page. We're going to do the same thing for example 5 as you did with 3 and 4. We're going to factor using synthetic or long division. So I'm going to start using negative 6 on the outside, and I'm going to put my coefficients 2, 7, negative 33, and negative 18 up top. I'm going to go through with my synthetic division. Right, so I have one factor, which is going to be x plus 6, because we know if we set that equals 0 and solve it, that we get negative 6. My other polynomial is 2x squared minus 5x minus 3, which we got from our synthetic division. Because the number in front of the x squared is something other than 1, we need to use the AC method to factor, which tells us to find two numbers that multiply to negative 6 and add to negative 5. So our options are 1 is 6 and 2 and 3. For our purposes, we're going to be using 1 and negative 6. So I'm going to keep the x plus 6 out front. Then we have 2x squared plus x minus 6x minus 3. And we can group the first two terms together and the last two terms together. If we pull out a greatest common factor, I'm left with x times the quantity of 2x plus 1. And if I pull out a negative 3 from the second one, again left with 2x plus 1. So this factors to x plus 6, 2x plus 1, and x minus 3. For example 6, it says for the given expression for the volume of a rectangular prism and sum of the dimensions, find the missing dimension. So we're missing this side length here. For this, we're going to use synthetic division again. So I'm going to use the coefficients up top, 3, 8, negative 45, and negative 50. And I can choose to use either of the side lengths, either x plus 1 or x plus 5. So if I use x plus 1 and I go through my synthetic process, I'm going to bring down my 3, multiply, add, multiply, add until I get to the end. Now this part's going to be different from what we did before. Instead of trying to factor that, because I know another 0, and that's the negative 5 coming from the other side length, I can take the resulting numbers on the bottom and I can do synthetic again. Notice as I'm going through the second time that I've switched the number out front, and we need to write out our answer polynomial here. Because the first one would have started with 3x squared, the next one becomes 3x. So this is 3x minus 10. That would have been our missing side length. If you are given one of the zeros of a polynomial, you can use the factor theorem and factor rules to factor the original polynomial completely and find the remaining zeros. Keep in mind that the number of zeros is the same as the degree of the original polynomial. What are the zeros of a function? A zero of a function is any x value that makes f of x equal to 0. Zeros are also referred to as solutions, roots, and x-intercepts. For example 7, given x minus 2 is a factor of f of x equals x cubed minus 8x squared plus 5x plus 14, they want you to find the rest of the zeros. So we're going to start once again with synthetic division. We're going to put our 2 out front and our coefficients up top. And I'm going to bring down the 1 and multiply and add. And multiply and add till we get all the way to the end here. So for this first one, I get x squared minus 6x minus 7, which I can factor into x minus 7 and x plus 1. And if it wants me to find the zeros, I'm going to take all three of my factors, not forgetting to include x minus 2, which it gave me originally. So x minus 2, x minus 7, and x plus 1. We're going to set them all equal to 0 and solve them all for x to get our three zeros. So we get x equals 2, x equals 7, and x equals -1. Please try example 8 on your own.